Today, I invite you to dive into the world of this groundbreaking battery. It represents not just power, but also your freedom to travel.
Now it's a quarter century. 25 years ago, we started business with this lithium.
For years, CATL engineers have been working on a silent revolution behind the scenes. No noise, no press conferences, just research, development, and waiting. And now, just when everyone thought EV technology had caught up, CATL has launched what has shaken up the entire EV industry. They have introduced their second-generation solid-state battery, and it has not only stunned the market, but has also emerged as a direct challenge to giants like Toyota. These batteries have extremely high energy density, rocket-fast charging, and unprecedented safety technology. CATL now has the three most decisive factors in the EV race. Now that solid-state technology is slowly becoming a reality, rather than a dream, CATL has launched not just a battery, but the key to the EV future. It has not only made Tesla and Toyota think, but has changed the rules of the entire EV game. So, is this solid-state battery the beginning of a new battery empire? And how this technology can change the entire future of EV? That's what we are going to know. But before that, subscribe to the channel now, so that next time, too, the latest information on technology reaches you first. Before we dive into CATL's game-changing battery, let us tell you a little about CATL. A company that once started in a small town called Ningde, China, has today become the biggest player in the global battery race. CATL was founded by Dr. Robin Jung, who had both deep experience and vision in battery technology. His dream was to take the world towards clean energy. That, too, through batteries that can power entire cars, not just small gadgets. When the world was only experimenting with lithium-ion batteries, CATL took the bold decision to enter the EV industry by focusing on this technology. Initially, CATL used to supply batteries only to domestic companies. But then, as the demand for EVs increased, CATL also expanded itself globally. Partnerships with big companies like Tesla, BMW, Hyundai, and heavy investment in its research took CATL forward rapidly. Today, CATL doesn't just make batteries, it designs the future. Working on projects like solid-state technology, sodium-ion batteries, and megawatt energy storage systems. What once started out of a lab has now become the heartbeat of the EV revolution. CATL's story proves that if the direction is clear and the thinking is sustainable, even a small seed can spread greenery across the world. CATL flips the script. When everyone in the battery world was running in the same race, CATL chose a path that others were not even seeing. While most companies were busy perfecting lithium-ion technology, CATL surprised the market with a completely new idea: sodium-ion batteries. This change was not just a technical upgrade, but a complete redefinition of the idea of energy storage. CATL's new move challenged the old belief that lithium was the only way. They showed that the battery of the future is not a fixed formula, but a canvas that can be sculpted by combining imagination and science. Sodium-ion batteries were until now overlooked due to their low energy density. That is, they could not store much electricity in a limited space. But CATL has turned this weakness into a strength. Their new generation of batteries is now on track to achieve efficiencies above 200 watt-hours per kilogram, which could bring them on par with current LFP batteries. And best of all, sodium is abundantly available. It's not expensive, easy to find, and doesn't rely on complex mining like lithium. Plus, its performance is said to be even better in cold climates, meaning these batteries could become a viable solution, not just an alternative. Lithium-ion batteries have certainly given a new impetus to the technological age. Everything from mobile phones to electric cars is dependent on them. But there is a harsh reality to this technology. the limited availability of lithium, and the growing global dependence on it. The environmental damage associated with mining, price fluctuations, and supply chain uncertainty are now making this technology unviable. This is where sodium-based batteries can be a game changer. Sodium is not an expensive chemical from a foreign mine, but is present everywhere in our Earth, in the salt, the sea, and underground. Not only does its abundance make it a strong option, but its low geopolitical pressure and environmental balance make it even more important. But don't think that sodium is just a cheap option. The fact is that scientists are looking at it as a platform that can better meet the needs of the future. Research is constantly being done to bring sodium-ion batteries to the level of lithium-ion, whether it is about increasing energy density or improving charging efficiency. This is not a cheap battery future, but a smart battery future is being created, a future that is more durable, safer, and reliable for a long time. The future of batteries. Imagine what would happen if batteries became as weather-resilient as we humans make ourselves. CATL is doing just that. They're not just building technology, they're making batteries work flawlessly in freezing cold and scorching heat. Their new sodium-ion batteries work efficiently in temperatures ranging from -40 degrees Celsius to 80 degrees Celsius. This means that EVs will no longer have to suffer from freezing in the cold or shutting down in the heat. And it's not just about performance, it's also about safety. In today's time, when every technology comes with a "what if the battery explodes?" fear, CATL's sodium-ion technology is becoming synonymous with reliability. This technology is considered much safer from incidents like thermal runaway, which are usually associated with lithium batteries. This change is not just a technological advancement. This is a turning point that opens up new avenues of reliability, durability, and accessibility in the world of batteries. Is affordable, clean energy possible for everyone now? As the world rapidly moves towards electric and renewable options to fight climate change, one question that keeps cropping up is, can these technologies be made accessible to everyone? The answer is yes. And the way to do that is through sodium-ion batteries. It's not just about technology, it's about cost. Companies like CATL know that great innovation isn't enough if it doesn't come within the budget of the common man. That's why they are investing heavily in batteries that are not only sustainable, but also much cheaper to make. Sodium isn't as rare as lithium, so its prices aren't as volatile. By 2030, prices could drop so low that the cost of manufacturing batteries will be reduced by 80% compared to today. What does that mean? More affordable EVs, access to clean energy in small towns and villages, and that too without heavy subsidies. And this transformation is not just limited to electric vehicles. These batteries could also make a big difference in grid-scale energy storage, a reliable way to store renewables like solar and wind power at scale, especially in places with extreme cold or unusual temperatures. As this technology advances, it will not only reduce our dependence on fossil fuels like oil, but also make energy markets more diverse and resilient. This transformation is not just a sign of a new battery, but a new, more equitable energy future, one where environmental protection and human access go hand in hand. Are we really moving towards a sustainable energy future? Now is the time not just to find new technologies, but to build an energy system that is flexible, reliable, and resilient. Imagine what the future would be like if dependence on one technology or one country ended, and electricity was affordable, safe, and easily available to everyone. Efforts have already begun to turn this idea into reality. Sodium-ion batteries are a big step in that direction. Yes, there is still a lot of improvement to be made. Work is going on many fronts, such as research, production scale, and integrating them into existing energy systems. But this change is no longer a distant thing, but is knocking at our door. This is not a race of any one company or country, but a global effort in which scientists, engineers, policymakers, and common people all are coming together. If we keep moving in the right direction, sodium-ion batteries will not only become an alternative to lithium, but can prove to be the backbone of a new energy revolution. Why choose sodium? Sodium is not a rare metal, but the sixth most common element on Earth. It is found in sea, soil, and salt, so it is readily available and extremely cheap. Sodium-based batteries are far cheaper to manufacture than lithium, making everything from electric cars to solar energy storage more affordable. But it's not just a cheaper option. It's a path that could lead us to affordable, sustainable, and reliable energy. If sodium-ion technology continues to progress in the right direction, the future could mark a new energy system for the whole world, one that is for everyone and lasts forever. Sodium-ion, safe and affordable. If batteries are changing our lives, it's not just about chemistry. The real revolution is when science meets innovation and practical engineering, and that's exactly what sodium-ion batteries are doing. CATL didn't just improve on conventional battery design, they redesigned its fundamentals. They used an advanced cathode called Prussian blue, so sodium-ion batteries now compete with lithium-ion batteries in terms of energy density, and in many cases beat them. The goal of this change was not just to create a battery, but to create a technology that was fast, stable, and had the best long-term performance. When this cathode was combined with a hard carbon anode, CATL's technology proved its worth. But performing well once isn't enough. The real challenge is to repeat the same performance again and again every time. Another big factor is the ability of these batteries to withstand temperature. Whereas lithium-ion batteries fail below -10 degrees Celsius, CATL's sodium-ion batteries work smoothly down to -40 degrees Celsius. This means that these batteries are perfect for snow-covered areas, cold climates, or places where energy is needed in the most extreme conditions. This is why their role in grid energy storage becomes even more important. Safety is another important aspect, and here too sodium-ion excels. These batteries are extremely unlikely to overheat or catch fire, and in CATL's testing, they have also passed rigorous tests such as puncture, which are considered a big challenge for lithium-ion cells. As the demand for battery storage is increasing and safety standards are becoming stricter, this feature is making sodium technology even more relevant. Now it comes to cost. By 2030, sodium-ion batteries are projected to reach prices below $100 per kilowatt-hour, roughly 80% cheaper than lithium. These numbers don't just do the math. They offer a glimpse into a future where clean energy is within reach of the common man. All of this, however, is possible under the condition that production is fast, manufacturing processes are refined, and investment in the industry is robust. Without robust gigafactories and a global production infrastructure, success in laboratories simply won't translate into reality. And this is not just a technical question, but also an economic challenge. For sodium to truly become an alternative to lithium, it must pass all kinds of real-world tests, thousands of charging cycles, everyday use, different climates. On top of that, we must reimagine the global battery supply chain. It will take new factories, billions of dollars in investment, and time. Lithium-ion technology took decades to get here, and while sodium is emerging rapidly, its journey will not be completed overnight. But one thing is certain. The path opened by sodium is not just an option, but is becoming a necessity of the future. As much as there is excitement around sodium-ion batteries, there are also challenges ahead. Yes, this technology has the potential to transform the future, but it is not an easy journey. The first hurdle is the lack of manufacturing infrastructure. Today's world has adapted to lithium-ion batteries. Factories, machines, supply chains, everything is focused on lithium. Adopting sodium-ion technology means investing heavily in new machinery, new resources, and a completely new manufacturing model. This is not a flip of a switch. Companies that want to enter this field will not only have to invest millions of dollars, but also enter an unexplored, untested market with confidence. And that is not everyone's cup of tea. Then there is the matter of recycling. Today, there is a stable recycling process for lithium-ion batteries, which is constantly being improved. But in the case of sodium-ion batteries, no clear system has been developed yet. If we adopt this technology on a large scale, we also need to ensure that the batteries do not become a burden on the environment after their lifespan is over. This is the biggest hidden question in future planning. What then? And don't think that the lithium giants will quietly retreat. They have decades of experience, a long list of patents, and billions of dollars of R&D capacity. They will not let any new technology flourish in the market. Sodium-ion proponents will have to prove not only technically, but also commercially, that their model is not only cheap, but also reliable and viable in the long term. This is not a battle between two battery technologies, but between two ideologies. On one side is an old, established empire that has been adapting to the times. On the other side is an emerging force, which is ready to take on every challenge in its quest for change. So yes, sodium-ion batteries have tremendous potential. But this does not mean that the path is straight. There are challenges at every turn, technical, economic, and competitive. But if the people walking on this path are determined, then one day this technology can really revolutionize the world of energy. Are sodium-ion batteries the real key to our clean energy future? As the world rapidly moves towards sustainable energy solutions, sodium-ion technology has opened up a new path. But like any transformation, the journey is not going to be easy. This is a revolution that needs time, patience, and a strong will. Because this is not a ready-made formula, but an evolving technology that faces new challenges every step of the way. But the importance of this journey cannot be overlooked. If we really want a future where energy is affordable, sustainable, and accessible to all, sodium-ion batteries can play a key role in that. From a technical perspective, these batteries are already challenging lithium-ion on several fronts. The Prussian blue cathode not only increases energy density, but also stabilizes the battery cycle life, which could reduce major problems like battery degradation in electric vehicles. Also, the hard carbon anode not only gives the battery better conductivity, but also a more robust structure, making it ideal for high-performance applications such as EVs and grid storage. Not just mechanical advantages, these batteries also have an edge in safety. Traditional lithium-ion batteries are based on liquid electrolytes, which can catch fire in case of high temperatures or damage. Sodium-ion technology comes in with solid-state electrolytes, which are not only more stable, but also improve both charging speed and safety. From an environmental perspective, sodium is superior to lithium in many ways. It is less toxic, more abundant, and relatively easy to obtain from seawater or salt lakes. This makes sodium-based batteries not only less harmful to the environment, but also makes their supply chain flexible, away from geopolitical tensions and mining disputes. The manufacturing process is also another big strength of these batteries. The production process is similar to lithium-ion, but the materials used are cheaper and less toxic. This reduces manufacturing costs and also reduces environmental impacts. That is, it is not only beneficial for consumers, but can also become a viable option for manufacturers. As far as applications are concerned, sodium-ion batteries do not limit themselves to just electric cars. They are also a better option for areas where temperatures are extreme, be it hot deserts or snow-capped mountains. Even in portable electronics like laptops and power tools, these batteries are capable of providing better safety and stable performance over a long period of time. Yes, it would be premature to say that this technology will completely replace lithium-ion batteries. There are still many hurdles to overcome, such as mass production, clear recycling structures, and systematic expansion of the supply chain. But if these challenges are addressed correctly, sodium-ion batteries could not only transform the current energy landscape, but also set a new standard for years to come. So, this shift isn't just necessary, it's inevitable. Can sodium-ion batteries become a real hope for recycling and the environment? As the world rapidly moves towards electric vehicles and renewable energy, the big question is, what will be the fate of all these batteries once their use is over? It is not enough to simply manufacture batteries, it is equally important to make them durable, and then be able to recycle them properly. And this is where sodium-ion batteries come as a big hope. Sodium-ion technology is designed from the start to be easy to recycle. Its internal structure is less complex than lithium-ion batteries, making them much easier to process. Several studies indicate that these batteries can achieve recycling efficiency of over 98%, and that too without leaving toxic residues. Lithium-ion batteries, on the other hand, are not only more complex, but recycling them can also be expensive and dangerous to the environment. The availability of sodium is revolutionary in itself. There are 23,600 parts per million of sodium on the Earth's surface, compared to only 20 for lithium. This difference not only makes sodium easier and cheaper to mine, but also makes its supply chain more flexible and less political. Furthermore, mining sodium has a much lower environmental impact than lithium. Issues such as water scarcity, land degradation, and pollution are almost negligible. Even more interestingly, sodium-ion batteries are manufactured using cheaper and more environmentally friendly metals, like aluminum, while lithium-ion batteries rely on expensive and more resource-intensive copper. This not only reduces costs, but also reduces the carbon footprint. Resource consumption-wise, lithium-ion batteries require a lot of water and energy to produce. In contrast, sodium-ion batteries can be produced with much less natural resources. This makes them a more sustainable option, especially when demand for batteries is growing by leaps and bounds. And it's not just environmentally friendly. These batteries also make a technological difference. As the share of renewable sources in the grid grows, the need for batteries that are not only durable but also offer stability and reliability to ensure a continuous flow of energy is growing. So, if we imagine a world where batteries are not only easy to use but also safe for the planet at the end of their life cycle, the answer seems clear. Sodium-ion batteries are not only friendly to the environment, but could also lead a new era of recycling. Are sodium-ion batteries the next big solution to keeping the power grid stable? As we become more reliant on renewable sources like solar and wind, the need for energy storage has grown more than ever. The beauty of these sources is that they are clean and sustainable, but their biggest challenge is uncertainty. Sometimes clouds cover the sun, sometimes the wind stops blowing. In such a situation, keeping the grid stable becomes a technical and economic struggle. Now imagine if you depend on your local power grid for daily electricity and suddenly there is a blackout. It will not just be an inconvenience, but your daily routine can come to a halt. Hospitals, traffic signals, data centers, or the coffee machine in your kitchen. Everything can stop. This is why grid stability is no longer a luxury, but a necessity. And it doesn't end there. Frequent power fluctuations not only damage equipment, but also have a huge impact on the entire infrastructure. Transformers, substations, cable systems. All of these are designed for the steady flow of power we no longer get. When energy supply drops or rises suddenly, these devices start to fail, costing millions in repairs. The economic impact of this instability is also profound. A small power cut can halt your entire office shift, halt factories, and impact everything from e-commerce to healthcare. That is, it becomes not just a problem of darkness, but a threat of entire system failure. And this is exactly where sodium-ion batteries emerge as a solution. These batteries can store excess solar or wind energy when production is high, and return it when it is needed. This maintains stability in the grid, without costly changes or huge expenditures. Lithium-ion batteries already exist in the field, but their cost, temperature tolerance, and resource limitations have often been a barrier. Sodium-ion batteries, on the other hand, are not only made from more affordable materials, but also perform better in extreme temperatures. This means they can operate smoothly from hot deserts to icy areas, and at a lower cost. And it's not just about energy or grid management. Sodium-ion technology is now being seen in other industries as well, especially in transportation, data backup, and smart city planning. The introduction of these batteries will reduce costs, improve performance, and set a new standard for battery-based technologies. All in all, sodium-ion batteries offer an alternative that can meet the needs not only of today, but also for decades to come. A solution that is affordable, sustainable, and capable of bringing new stability to our energy system. If you found this information useful and want to be the first to know about future technology, energy innovation, and such in-depth research, then subscribe to our channel now. Your one click inspires us to create more such content. Don't forget to like the video. It tells us that you want more of such content. Do share your thoughts in the comments below, and share the video so that more people can know about this revolution. See you in the next video. Till then, thanks.